Hello and welcome. This is Anadhufu Show. I'm Anwar Khalil with the program. And my guest today is an instructor at Adisaba University, in the Faculty of Natural Sciences, of course. And he is an astrophysicist, Dr. Ramuddin Rashid. Anadhufu, Doctor.
Anadhufu, thank you.
You're young, but PhD holder. But before talking about that, I'm going to ask you about your upbringing and the way you grew up and where were you born and how did you grow up there around?
Yeah, I am from Bekoji, RC Bekoji, and I grew there. So at the early age, around 5 years old, then I joined a primary school at Tigilfrey Primary School.
There in Bekoji Town?
In Bekoji Town. I studied there, and 7th and 8th grade, I enrolled to another school, which is also in the same town. It's Bekoji Malestanya, which is basically junior school. Then on the 9th, starting from 9th grade, then I completed at Bekoji Senior Secondary School.
I mean, when we talk of Bekoji, what comes to the mind of many people around the world is about the athletics. Haven't you tried that athletics there? Because even I heard, remember that the jungle, the forest where the training, athletes exercise and around there is closer to the high school. This is the information I have.
That's true.
Did you try that?
I haven't tried myself, but not specifically to be like athletes, but everybody has been like, who is living in that town has been inspired by the athletes, the outcome they had in the athletic arena, and so the challenges that they go through. And so it's not only from Bekoji, also even Haile Gebrselassie in Asala, the movies that was actually endurance. Seeing all these things, people get inspired, and you see a lot of kids basically in the surroundings going running around like in the early morning and so on. So I think I was part of that, but not intentionally to become like an athlete.
Athletics is a culture in Bekoji area, and many renowned athletes like the famous Daratu Tuluk, and Runushti Baba, and many more.
Yes. Actually,
they came from that ground, and probably the environment, I mean, the climate of the area has that impact on athletes, and also the courage. The courage is there.
Exactly.
And let me be back to you. You completed the high school there, and then joined Adisaba University, I think.
Yes.
And what did you study there?
Yeah, so in that program, I think in Ethiopian year, that is 1994, there was students from previous years that were enrolled at Adisaba University. There was some problem at the university, and the students were out. So most of the students who were assigned even at the universities outside Addis were to enter Adisaba. So for that, we stayed at Adisaba University for half a semester before we moved to Hawassa University. I think the so-called, at that time it was called Hawassa University. So that was a freshman year. And then I moved to Hawassa University. It's called actually Dabub University by then.
But then no Hawassa.
Yeah. Okay. And Dabub University comprised of the 3 universities, Hawassa, Dilla, and Wendogennat
University.
Yeah, exactly. And then the second year, after completing the first year, then you have to go through kind of lottery system, basically to choose the departments that you want to join. So then among the departments that fulfills my interest in that area was physics. So then I decided to join physics at Dilla, because physics was provided by then at Dilla. So I joined Dilla starting from second year to the last year, fourth year. I was studying at Dilla University. physics. Yes.
What about your second degree? I think you know somebody who knows you told me that you've got two MSCs.
That's true. Okay, so
what can you tell us about that?
Yeah, I completed my bachelor in physics from Dilla University, and before finishing, actually, I applied for to continue my master's.
There at Dilla University.
Yeah, because I was always motivated at that time to even now really more physics. So then I said it's really important for me to have a possibility to continue my education doing masters in physics, in some field of physics. But there was an inclination already toward this astrophysics. I don't know exactly if I am going to join doing specifically astrophysics for my master's degree, but there has been like things that I exposed to the books that I read are attracting me towards astrophysics at that point.
Yeah, I was Googling, you know, this astrophysics. Astronomy by itself is a big hard science.
Yes.
And physics, everybody knows, an engine. Physics is their heart.
Yeah.
And it's not you know, a science that is well known in our country.
Exactly.
How dare you dare that?
Yeah, so I think it goes back to where we were listening to FM radio prepared by the late Dr. Legasser Wasro.
Oh, from say RC.
Yeah, usually he's explaining this in Amharic, and you see most of the objects he was talking about are quite exotic. The behaviors that they show, you may listen to, for example, an object as massive as that of a sun spinning, basically turning, probably like completing an oscillation maybe 1,000 times per second. So this is really hard to bear such kind of phenomena happening. So you find quite exotic behaviors within this kind of the fate of the stars, the later stage of the stars. And so it was catching my attention from that earlier time on. Then joining physics at the third year of physics, I get to read this book. It was also a mixture of religion and physics, astrophysics. Then that shows about the existence of really these exotic objects like white dwarf, neutron star, black hole, and so on. Then I said, okay, there are really vast things to be discovered, to be read, and to be inspired of. So maybe that is the thing that has actually attracted my attention when I joined for my master's at Addis Ababa University. So
you completed your MSc in astrophysics at Addis University, the first part.
Yeah.
And you're the student of Dr. Legasser Wasro, yes. Smart guy. I know that person in person as well.
Yeah.
And these things are even hard to imagine about cosmology, about the black hole. Stephen Hawking, the late scientist, the British scientist, and he talks a lot of things about time and this black hole.
That's true.
And how can we imagine that where we don't have that technology to understand things? How do you understand? Even people don't understand the 9 planets we have been talking about, you know, including that ice, that dry ice, Pluto.
Yeah.
People think we cannot imagine as the planets are in order on their orbits and whatever. We do not easily understand that. How come you understand it?
Yeah, so I think it is like the nature of humans basically to ask from day one, they look basically up the sky and the sea basically that the sun exists, and then they try to see things that happens around them, the change of the seasons and all these things. So they associate, I mean, from the earlier age, like from 6,000 years ago, for example, you see in Mesopotamia people put a number to this kind of happenings. Yeah, exactly.
Okay.
So they define, for example, circle to be 360 degrees, which means it is the path the Earth has to go around the sun, or vice versa, basically for completing 1 year, which is around 365 days. So, and also when the sun moves around the sky, so you find basically spending between different constellations in the sky, so around 12 constellations, so they divide basically that into 12 months. So you see basically people are now moving as time goes on to answer this kind of question. And it came slowly to where people have to study these things scientifically. So I think the accumulated knowledge over time and getting well structured to answer all the questions that comes into humans is actually what is basically enabling even to answer such complicated science. I mean, in the early 20th century, by 1900, I mean, the golden age for the scientists where Einstein has lived. You see basically the main science getting well compiled, where they combined space and time. So that usual dimensions that you have for space, you may think it's from simply the three coordinates that we have, X, Y, Z, and then you add basically to describe an event, time. And so the beauty of compiling these things and seeing light, for example, differently enabled what we call a special theory of relativity, which is basically a real phenomena which could be tested with things that moves faster. If they go with a relative stick speed, then you see various beautiful phenomena. Could be the time, for example, is not absolute. It could be dilated when it is described from different reference frames. Yeah. So that means time could be stretched. So so this brought like a different way of viewing space and time, and by combining them. So once special relativity came, and then which basically the main objective of it is so that the laws of physics obeys, they could be run or keep their own form, the same form. They should be applicable to a reference frame that could equally move with a constant speed away from the first reference frame, so that the main idea is to keep the laws of physics basically keeping the same form, and things could be described equally well in different reference frame. So this idea then were further developed within the next 16 years. Around 1916, then Einstein, for example, has published what we call general theory of relativity. Yeah, this one now come up with even more stuff, like combining space-time and basically seeing the effect of the matter and describing what we call gravity, basically, which was far-reaching and is among the four type of forces that we know in nature. It is basically what we call a long-range force. So you find objects like the moon and, for example, the Earth, basically interacting each other with this kind of gravitational force. You find basically different stars at different distances within a galaxy interacting gravitationally. So this is like, it's basically covers a wide range, a bigger range in the covering the interaction of particles or objects.
Like there are forces like the centrifugal pressure is also keeping the distance among the planets, and also the galaxy, Milky Way, all the matters in the universe. Like that. And by the way, for the contribution of your science, Copernicus and Galileo Galilei have also done a great thing.
Yes.
Nicola Copernicus, because great contributors. Even Aristotle, that his theory was heliocentric. He was saying the sun was the center.
Yeah.
Copernicus actually got that, and Aristotle said land is the sun, Earth is the center, and Copernicus disproved that and said heliocentric.
Exactly.
All right, we'll be back to that point. Okay. But let's talk about your job after graduation. Yeah, you can drink your water. After completing your master's degree, where did you do? I mean, your occupation, a kind of at the same university or somewhere else?